Okay, welcome to my YouTube channel, Physics Matters. Today we talk about the so-called horizontal throw. And last time we talked about the vertical throw and also free falling objects. So now we go one step further and take a look at objects that have an initial speed in x direction. So we will start with our equation of motion, or equations of motion, we have to say, because we will find out that we actually get two, depending in which parameter space we are writing it down. So now we can draw our coordinate system. For example, it could look like that. And again, we have our three components, x, y, and z. And then we have an object here somewhere with a certain height, above the ground level. Let's call it h. And then we can draw our trajectory in the following way. So how we can describe this, we will see in a few minutes, but let me write down a few more values. And in this case, actually it's mainly the initial speed v0, or we can also call it vx0, because we have only initial speed in x direction. And our speed in y direction, it increases within time. So the value in x direction remains constant. The value here would be exactly the same as we have here, and also exactly the same as we have here. But our speed in y direction increases within time. And we can calculate this by writing down our equation of motion in the most general way, which is 1/2 at square plus v0 t plus s0. And then we can take a look at these two components in x and y direction individually because of the so-called superposition principle. This is a very important principle, as I said last time, and it allows us now to describe the trajectory of our object in an easy way. So, as I said, we need two equations. The first one will be to describe our x component, which is x of t equals to, and then we have only, as I said before, a component in x direction, which means that this would be yx0 times t. Since it only has an initial speed in x direction, we can also ignore this x here, and we can just write v0t. And now in z direction, in the two-dimensional diagram it would be y direction, but now we call this x, so now we call that z. So we can write here z of t equals, and then again we do the same what we have done for the vertical shot, or for the vertical throw. We have to replace a with g and a minus in front, so we have to write minus 1/2 gt square. The initial speed is 0, so what remains is s0, which is the height, so we can simply write here plus h. And now we have two equations of motions with which we can then calculate everything that we need in order to find certain parameters of our horizontal throw. So the first thing which I would do, I would like to insert equation 1 in equation 2, and this gives us z of x. So now we replace the parameter t with the parameter x. This would be z of x minus 1/2 g. We get our x here, which would be x squared now, divided by v0 squared plus h. And this is also a very important formula. So now this is describing our z component as a function of our x value. And we can see we have a quadratic dependency between z and x. So this exactly results in a parabolic shape. So we have half of a parabola here in this case. And I can also, for completeness, I can also write down our g, which would be in this case constant. It would be always here G here, G, and here G. And as I said, our V in Z direction increases. So here it would be 0 in the first place. Then here it increases further, and here it even gets larger to Vy, which is just simply G times the time. So what we can, for example, calculate with this is our maximum distance. Calculating a maximum height would not make any sense because the height is not increasing, but we can calculate the maximum distance, which means that if we have here coordinate system, for example z and x, then we want to calculate the distance from the origin to the place where our object hits the ground. So now in order to calculate this, we have to write down our equation z of x, which was given as -1/2 g x squared divided by v0 squared plus h. And then we can set this equal to 0. If this is 0, then the z component will be 0, which means the ball or the object will hit the ground. So now we can subtract, in order to solve this, h on both sides, which at the end results in -1/2 g x squared divided by v0 squared equal to -h. And then we can, of course, multiply both sides with -2, and this then leads to g x squared divided by v0 squared, which is equal to 2 times h. And then in the next step, we can then directly divide by g and multiply with v0 squared, and this results in x squared equals 2h v0 squared divided by g. And then the only thing which we have to do, we have to calculate the root, the square root, and this then results in x, in principle plus minus, but again we can reject the negative value. It leads to an unphysical value, so we can write here directly our xd equals to 2 times h divided by g v0, and then we have to calculate here the square root. This is then our equation for the maximum distance. So again, this is a very important formula, and I would like to highlight that once more. And now we can also make an example. So let's suppose we have again a house. I think this is the most easiest one which I can imagine. And somebody is standing here on the roof again, and he has an object in his hand which he then throws, and then we can see this half parabola shape of the trajectory. And we have an initial speed of v0 equals to 10 meter per second, for example, and we also want to give a height here from our object to ground level, and this would be given as h equals again 10 meter, because we will see later that many things cancel out when we use these values. Then we calculate the distance, this maximum distance, with the formula that I have stated before. So we have to insert now our values. Xd equals to 2h divided by g square root times v0. And when we do that, our h value, our height is 10 meter. And here we can write 10 meter per square second, as I said last time, times 10 meter per second. And this is the reason why I think it's very nice to write it in such a way, because now we can cancel out here these 10, which then leads to square root of 2. 1 over square second, which gives a second, times the second here gives directly a result of 10 meter. And now if we if we calculate our square root of 2, it will get 1.4, which at the end results in approximately a distance of 14 meter. Now what we can also calculate, for example, is the impact speed, with the speed with which the object hits the ground. So what we can do here, we can take a look at the vector components of the object when it hits the ground. And as I said, we have now component in x direction, and because our speed in y also increased, so we have now a component in y direction. And in total, this results in a vector v, which is the which we can just calculate by vector addition of these two components, because as I said last time, we have superposition principle that we can apply. So now we can use the theorem of Pythagoras in order to calculate v, which means we can write v is square root of vx square plus vy square. The only question is, what is our vx and what is our vy? Yeah, so as I said before, vx does not change in time. Yeah, so now the question is only what are vx and what. Now the question is only what is vx and what is vy, how we can calculate them. And as I said in the beginning, vx is constant. It is just our initial speed v0, and our value vy would be given as minus g times t, acceleration times time, as we have also said before. And if we insert this into our equation here, then we would get actually get the following. We can write now here v, the total speed is given as square root of v0 square plus g times t squared. And we have already seen that we can also calculate this time now. We have already seen for a free falling object that our time is given as t equals 2h divided by g, and then the square root from that. And the reason why we can use this formula is because in y direction, because of superposition principle, in y direction our object falls exactly how an object would fall if it is a free falling object. So in this case we can just use the same formula, and this at the end, when we insert that, we get for the total speed v equals v0 squared plus 2gh. Yeah, and this is our impact speed, so we could call it, for example, vi, and then we can also highlight this because it is a very important formula that we will use. And again, I would like to make an example for clarification. So we use again this person standing on the roof, and again we will use an initial speed of 10 meter per second, and we have a height of 10 meter. Then our impact speed vi would be given as we have said before, square root of v0 squared plus 2gh. So this then results in square root of v squared is just 100 meter per second squared plus 2 times 10 meter per square second times the height 10 meter. And this gives a value of 200, and this gives a value of 100. So at the end, this results in square root of 300 meter per second. The unit we can now already take out from this root. And this results in approximately 17 meter per second. So the total speed with which our object hits the ground is not 10 meter per second, but 17 meter per second, because it gained now an initial speed in y direction as well. And what we can also calculate in addition to the speed is the impact angle, which I think is also a very important quantity. Yeah. So again, if we have here our object, we can write down our components for the velocity, vx and vy. And then again here we would have our total speed, or total velocity vector, but the absolute value would be the total speed. And then we can also define an angle here, for example this one, which would be the angle between the velocity vector of the object and the ground level. So in this case, this angle is actually what we want to calculate. Yeah, because Vx and Vy is given, we have to calculate now tangent alpha given as Vy divided by Vx. And we have already said before that Vy can be calculated as minus gt. And our value in x direction does not change. This is again V0. And then again we can insert our time of a free falling object, which is 2 times h divided by g. So from this it follows tangent alpha, this would be then equal to minus g, and then we have to write here our square root 2h over g divided by v0, and this at the end results in minus square root 2hg divided by v0. And again, it's an important formula, so I would like to highlight that. We can make an example, as always. So what we can do, we can again take our initial speed as 10 meter per second and our height as 10 meter, the same example as we have used before. Then our impact angle would be given as alpha I, and then the inverse tangent. And we can actually ignore the minus sign in front, yeah, just to make it easier. It will lead to the same result. So we can write here 2gh divided by 20, and then the square root from that. This is our formula that we have stated before. And this then gives, if we insert all values, this will result in 2 times 10 meter per square second times 10 meter divided by 10 meter per second. And here we also have to write the square root. And this is approximately, or this is equal, the inverse tangent of 10 times 10, which gives 100. The square root of 100 is 10. 10 divided by 10 is 1. Yeah, and also all the units cancel out, so we have the inverse tangent of square root of 2, which remains. And if we type this into our calculator, we get a value of around 55 degrees. This is actually the impact angle under which the object will hit the ground. Okay, this is everything which I want to tell you today. I hope that you enjoyed the video and you learned something new. Thank you very much for your attention, and hopefully see you soon for a new video. Thank you very much for watching this video. If you like the content and want to see more of it, please like and subscribe. And in addition, any kind of support is always appreciated.